Welcome back. In our last episode, we introduced the world of large language models and gave you a roadmap for this series. Today, we are diving into foundation models.
This is such an important topic because foundation models have really transformed the AI landscape in the past few years.
So, let's start with the basics. What exactly is a foundation model?
A foundation model is a large scale model that's trained on broad, diverse data and can be adapted to a wide range of downstream tasks. The key idea is that you build one powerful base model and then you can fine tune it or adapt it for many different specific applications.
Think of it like building a foundation for a house. Instead of constructing a completely new building from scratch every time, you create a strong foundation that can support many different structures.
Exactly. Before foundation models, if you wanted an AI system to do medical diagnosis, you'd train a model specifically on medical data from scratch. If you wanted another system for legal document analysis, you'd start over again with legal data.
But with foundation models, you start with a model that already understands language, context, and reasoning from its broad training. Then you just specialize it for your specific task.
This approach has several huge advantages. First, it's much more efficient. Training a large model from scratch requires enormous amounts of compute and data. Fine tuning an existing foundation model requires far less of both.
Second, foundation models often perform better because they've learned general patterns and knowledge that transfer well to specific tasks.
And third, it democratizes AI. Smaller organizations and researchers who don't have massive computing budgets can still build state of the art applications by starting with foundation models.
Let's talk about some examples. What are the most well known foundation models?
GPT from OpenAI is probably the most famous. GPT-3, GPT-4, and now GPT-4o are all foundation models trained on massive amounts of internet text, books, and other sources.
BERT from Google is another major one. BERT stands for Bidirectional Encoder Representations from Transformers, and it was one of the first foundation models to show the power of this approach.
There's also T5 from Google, which frames all tasks as text to text problems. Claude from Anthropic, which we're having this conversation with, Llama from Meta, which is open source, and many others.
Now, what makes these foundation models so capable? What are they actually learning during that initial training phase?
During pre training, that's the term for the initial large scale training phase, these models learn an enormous amount of general knowledge and capabilities.
They learn grammar, syntax, and how language is structured. They learn facts about the world, history, science, culture, and more. They learn reasoning patterns and how to solve problems.
They also learn to understand context. When you read a sentence, the meaning of each word depends on the surrounding words. Foundation models become very good at capturing these contextual relationships.
This happens through what's called self supervised learning. The model is trained to predict missing or upcoming words in text, and through this simple task, it develops sophisticated understanding.
Let me give you a concrete example. If the model sees the cat sat on the pear, it learns to predict mat or floor or other plausible words. But it's doing this billions of times with all kinds of sentences, so it's learning the patterns of language itself.
And because the training data is so diverse web pages, books, scientific papers, code, conversations the model builds knowledge across many domains.
Now, an important concept here is the corpus or dataset mixture. Foundation models aren't just trained on one type of data, they're trained on carefully curated mixtures of different data sources.
The exact mixture matters a lot. Too much of one type of data and the model might be biased. Too little diversity and it won't generalize well.
Research teams spend enormous effort on data curation, selecting, cleaning, and balancing their training data. This includes deduplication to remove near duplicate content, which helps prevent overfitting.
They also apply safety filters and PII scrubbing, that's personally identifiable information scrubbing, to remove private data and harmful content from the training set.
Once you have a foundation model, how do you actually use it for specific applications?
There are several approaches. The most common is fine tuning, where you take the pre trained model and continue training it on data specific to your task. We'll dive deeper into this in a future episode.
Another approach is few shot or in context learning, where you don't change the model's parameters at all. Instead, you just provide examples of your task in the prompt, and the model learns to imitate the pattern.
There's also prompt engineering, where you carefully craft the input to guide the model toward the behavior you want.
What's remarkable is how versatile these foundation models are. The same base model can be adapted for question answering, summarization, translation, code generation, creative writing, and countless other tasks.
This versatility comes from the scale and diversity of pre training. The models have seen so many examples of different tasks during training that they've internalized general problem solving abilities.
Of course, foundation models aren't perfect. They can hallucinate. That's when they generate confident sounding but false information. They can reflect biases present in their training data, and they require significant computational resources to run.
But despite these challenges, foundation models have become the backbone of modern AI applications. They represent a fundamental shift in how we build AI systems.
Instead of training specialist models for every single task, we now build general purpose foundations and adapt them as needed. It's more like how humans learn. We develop general cognitive abilities and then apply them to specific domains.
So, to sum up, foundation models are large scale, broadly trained models that serve as the starting point for many AI applications. They learn through self supervised pre training on diverse data, and they can be adapted to specific tasks through various techniques.
Next episode, we're going to take a step back and look at the evolution of neural networks, how we got from simple perceptrons to the sophisticated deep learning systems that power today's foundation models.
Thanks for listening. If you are enjoying this series, share it with someone who's curious about AI.
Until next time, keep learning and stay curious.